Okay, using intercepts, section 8.3. Now this is a second method at graphing equations. Rather than the t-chart, the second option is to use intercepts. And what we're going to see is most every graph that we make is going to have an x and y intercept, which is why this works. When you have a coordinate that you're working with, as long as you have 2 points for that line, any 2 points, maybe this point and this point, you can always figure out what line goes through them. Because all you have to do, you need 2 points. If you only had 1 point, then the line could go like this, or like this, or like this, or like this, or like this, any which way. But as long as you have 2 or more, you can definitely figure out what specific line that is. And that's what we can see here. If we can find 2 points, we can make the line. All right, now most all equations are going to have an x-intercept and a y-intercept, so those can be our 2 points. So let's look at what they are specifically. The x-intercept, and I have a line drawn in here with the points labeled. The x-intercept is where your graph, the line graph, is going to cross the x-axis. It's where they intercept one another. Okay, so here's my x-axis, here's my line. Notice they intercept one another right here. So my x-intercept in this case is at the point -3, 0, or when x equals -3. That's where they cross. Now my y-intercept is where the graph is going to cross the y-axis. So here's my y-axis, here's my graph. They're crossing at the point -2. So my y-intercept is where the graph crosses the y-axis, which in this case is 0, -2, or at y equals -2. Just for a quick practice of another point, if I choose right here and right here, and make a line, suppose that went through it, okay, my x-intercept here would be this point right here, because this is where it's crossing the x-axis, which is -1, -1, 0. My y-intercept is where it's going to cross the y-axis, which is right here, 0, 1, or y equals 1. Okay, so we can practice, and we do in class practice with a few other lines to get comfortable with what our x and y intercepts are. X is where it crosses the x-axis, y is where it crosses the y. Now, in this gray box is an explanation as to how to find the x and y intercepts. It is a good explanation. It's an excellent mathematically based one, but it can get a little bit confusing. There's an easier way, which we'll think of as the cover-up method. So let's go through and explain why the cover-up method will work, and then we'll go on to actually use it, and you'll see the easy way to figure out these 2 points. Now before we go on, so what we're looking at here is that notice my x-intercept was -3, 0. For my x-intercept, my y is 0. For my y-intercept, my x is 0. So they're like backwards. X-intercept, y is 0. Y-intercept, x is 0. So essentially what I do to find the x and y intercept, if I want the x-intercept, I plug 0 in for y. If I want the y-intercept, I plug 0 in for x. And that cancels things out. Like we said though, an easier way of thinking that, and so that you don't have to actually be substituting a lot of values in, is to do something known as the cover-up method, or you put your finger over it, the finger method. There's a whole bunch of different ways of calling it, but and it will be a little bit hard for me to show you that right here. I'm going to try to do it this way. But let's see if I can go ahead. We don't want that little thing. I'm going to go ahead and I'm going to pretend this square is my finger, okay? Like we said, it's called the cover-up method. So basically, I can, if I want the x-intercept, I'm going to cover up the y portion. And because this negative goes with the y, I'm really covering up that whole thing. Now notice what I have left when I cover that up. 3x equals 6. 3x equals 6, when I do that, I can solve that for x, divide both sides by 3. Those cancel, x equals 2. Voila, that's my x-intercept. Okay, and it was as easy as that. Oopsies. Let's go ahead and let's try to find our y-intercept. I'm going to start with the same equation. 3x minus 2y is equal to 6. And I'm going to go ahead, and this time I'm going to cover up. Oh, don't want to move that. We'll just bring down another square. I'm going to cover up the 3x. Now I don't cover up that minus sign because that minus goes with the 2y. So now I have a new equation. Now I have negative 2y equals 6. Divide by negative 2, divide by negative 2, y equals negative 3. That's my y-intercept. I can plot both of these points. X is at 2, 1, 2. It's my x-axis, my y. Y is at negative 3, 1, 2, 3. Connect them, obviously a little straighter than what I just did there, and you have your graph. Okay, so let's practice a few more of these using just this simple option of covering things up. All right, so part A. First, it doesn't matter which I cover up first. I'm going to choose to cover up, oh, I don't want to, I'm sorry. Sorry for the back and forth with this, but it's the easiest way to do it. I'm going to choose to cover up the y, so I end up with x equals negative 2. So my x-intercept is negative 2 because that's just what we see on the screen. Now I'm going to go ahead and choose to cover up the x. And I'm going to get, that's my a value, so negative 2y equals negative 2. To go ahead and graph this, I divide by negative 2, divide by negative 2. That becomes 1, so y equals 1. So my y-intercept is 1. 2 points are determined. I'm able to graph. X is negative 2, y is 1. Ooh, connect them in a straight line, and there you have your graph. Okay? So that's all there is to it, determining your x and y values just like that. Before we go on to do letter B here, I want to practice one right below here. So if you want to just kind of add it in with me. Let's try this. If we have 4x plus 3y equal to 12, I want to determine what my x and my y intercepts are. Okay, we're not going to graph it in this case. I just want to practice with the x and y intercepts. Okay, so first I'm going to cover up the y value. Divide by 4, divide by 4, x equals 3. So my first is my x-intercept, which is going to be 3. Then I'm going to go ahead to find out what my y-intercept is going to be. So I'm going to cover up. That was a positive 3, so I can cover up the plus. Now I have 3y equals 4. So I'm going to divide both sides by 3, and when I do that, I find that y equals 4. Okay, so really here I divide by 3, and that was work from before. X equals y equals 4. So my x-intercept, just for extra practice here, we found that it was 3. My y-intercept, for extra practice, we found that y equaled 4. So x equals 3, y equals 4. Now if I wanted the point, my x-intercept would be 3, 0, because it's where it would fall if we wanted to see a visual representation. It would be 1, 2, 3 on the x, so 3, 0. My y-intercept would be 0, 4 if I wanted the ordered pair. Okay, and that's what the graph would look like, but it's also important to recognize how you could get the ordered pairs. The point here, if we wanted the ordered pairs, would be negative 2, 0, and this would be 0, 1. Okay, and if we look up to what we found our x and y intercepts to be, this is how we would get it. We could just say, oh, x is going to be negative 2, 0, my x value. My y here is going to be the 1, so the other point must be 0. Okay? Now notice I left B